Recently, the United States Navy released its updated long-range shipbuilding plan, and it contained a sobering reality check. Starting in 2030, the very first batch of Arleigh Burke-class destroyers will officially begin to retire, and once the first batch goes, the second batch will follow. Since the lead ship was commissioned in 1991, this single class of warship has defined American maritime hegemony. It is the most numerous post-World War II surface combatant in the US inventory. It wrote the book on what a modern Aegis warship is supposed to be, and its design DNA has been copied by nearly every modern navy on the planet. For 40 years, this ship has been the undisputed workhorse of the fleet, but its hull has been upgraded, modified, and squeezed to its absolute physical limits. The ship simply cannot generate the electricity required to power the laser weapons and railguns of tomorrow. So, what happens when the greatest destroyer in history finally steps down? Who takes over? And more importantly, after so many failures, does the American shipbuilding industry actually have the capacity to build a successor? If you look at the sleek, iconic silhouette of an Arleigh Burke today, it looks like a masterpiece of engineering. But back in the 1980s, the initial design phase was an absolute nightmare for naval architects. During the Cold War, the US Navy developed the Aegis combat system, a revolutionary radar and computer network designed to shoot down massive swarms of Soviet anti-ship missiles. They put this system on the Ticonderoga-class cruisers. The problem? The cruisers were massively expensive, and the Navy couldn't afford enough of them to protect the fleet. So, the Pentagon walked into the Naval Sea Systems Command with an impossible mission: take the massive Aegis radar system off that cruiser and stuff it onto a smaller, cheaper destroyer. To a naval architect, this request was the equivalent of trying to stuff an elephant into a mouse hole. The core of the Aegis system relies on 4 massive, passive, electronically scanned array radar panels. Each of these iron plates relies on tens of thousands of pounds. To see over the curvature of the Earth and detect sea-skimming missiles, these incredibly heavy plates must be mounted high up on the ship's superstructure. Traditional destroyers were designed to be long, narrow, and sleek to achieve maximum top speed. But if you take a narrow ship and strap 100 tons of radar to the top of the mast, you completely destroy the ship's center of gravity. It becomes incredibly top-heavy. In a heavy storm or during a high-speed hard turn, that ship is going to roll over and capsize. Faced with a physics dead end, the designers of the Arleigh Burke had to make a decision that went against centuries of naval tradition. They decided to make the ship fat. They completely abandoned the long, elegant Greyhound-style hulls of the past. The beam, the width of the Arleigh Burke, was stretched to over 66 feet. The length-to-beam ratio was drastically compressed. From the front, it didn't look like a sleek hunter. It looked like a bulldog with an incredibly wide stance. This deep V ultra-wide hull design sacrificed some top-end speed, but it completely solved the center of gravity issue. It allowed the massive SP-1 radars to sit high on the superstructure, while ensuring the ship remained incredibly stable. Even in atrocious sea states, an Arleigh Burke punches through the waves like a weeble wobble, keeping those radars locked on target. But solving the weight issue was just the beginning. The engineers inadvertently kicked off a revolution that would define naval warfare for the next 30 years: radar stealth. Prior to the Burke, warships were built with vertical walls and lattice masts, covered in antennas that looked like metal clotheslines. The Arleigh Burke was the first mass-produced surface combatant in human history, specifically designed from the keel up to minimize its radar cross-section. Look at the superstructure. There is not a single perfectly vertical flat surface on the exterior of the ship. Every wall is angled inward or outward. The traditional lattice mast was replaced with a raked tripod mast. Even the lifeboats and missile launchers were tucked behind angled bulwarks. This made the 8,000-ton destroyer look significantly smaller on enemy radar, allowing it to hide in the electromagnetic clutter of the ocean. But hiding was only half the battle. To pack a punch, the designers had to make a brutal sacrifice. They eliminated the helicopter hangar. Early Flight 1 Burkes had a flight deck, but no hangar to store and maintain a helicopter. Why? because the designers used all that internal space to dig massive holes in the deck. They crammed 90 Mark 41 vertical launch system cells into the bow and stern of the ship. This gave the Burke, despite its smaller size, roughly 75% of the firepower of a Ticonderoga-class cruiser. These 90 cells acted as a universal socket. The ship could mix and match standard missile series for air defense, Tomahawk missiles for deep land strikes, and Ace Rock missiles for hunting submarines. It was both an impenetrable shield and a devastating spear, and if it took a hit, it was designed to survive. In the 1970s and early 80s, navies loved using aluminum superstructures to save weight, but aluminum melts and burns at low temperatures. After the devastating fires on the USS Belknap and British ships in the Falklands War, the US Navy swore off aluminum. The Arleigh Burke was built entirely of steel. Furthermore, the Combat Information Center was moved off the bridge and buried deep inside the hull, wrapped in 130 tons of Kevlar spall armor. Even if a Russian anti-ship missile obliterated the bridge, the crew buried in the CIC could still fight the ship. It was also the first destroyer equipped with a collective protection system to seal the ship against nuclear, biological, and chemical fallout. When the lead ship was launched, the legendary World War II Admiral Arleigh Burke himself proclaimed, "This ship is built to fight. You have the best warship in the world." Fast forward 20 years. By the late 2000s, the Navy looked at the Burke and decided it was getting old. They wanted something new, something out of a sci-fi movie. They poured tens of billions of dollars into the Zumwalt-class destroyer. It featured an extreme tumble-home hull, an integrated power system, and advanced gun systems. It was supposed to be the ultimate replacement for the Burke. But the Zumwalt was an absolute catastrophic failure of procurement. The technology was too immature. The advanced gun system was useless because the ammunition was too expensive to fire. The costs spiraled completely out of control. The Navy originally planned to build 32 Zumwalts. They stopped at 3. Furthermore, a planned CGX next-generation cruiser was completely canceled before it even left the drawing board. The Navy was in a state of absolute panic. Their futuristic replacements were dead. They realized that the only ship capable of fighting a high-end war that they could actually afford, and that the shipyards knew how to build, was the trusty, decades-old Arleigh Burke. So the Pentagon forced the production lines back open, and this unexpected resurrection pushed the Burke to the absolute pinnacle of naval warfare. Since there was no new hull design, the Navy began aggressively upgrading the guts of the Burke. The Flight 2A variant extended the hull and finally added dual hangars for 2 MH-60R Seahawk helicopters, massively expanding the ship's anti-submarine radius. But the real magic happened in the software. As Chinese and Russian ballistic missiles became a severe threat, the Navy executed technology insertions. They installed the Aegis Baseline 9 system. This gave older-looking hulls a superhuman brain. With Baseline 9, an Arleigh Burke can now perform integrated air and missile defense. It can simultaneously track and destroy a sea-skimming anti-ship cruise missile while guiding an Anduril Missile 3 interceptor into outer space to smash an incoming ballistic missile. It is multitasking at the highest, most lethal level of physics. The newest variant, the Flight 3, takes this even further. It replaces the old SP-1 radar with the vastly superior AN/SPY-6 active electronically scanned array radar, multiplying the ship's detection range and precision exponentially. But to power that massive new radar, the Flight 3 completely maxed out the ship's physical capacity to generate electricity and cooling. The Arleigh Burke hull is officially out of room to grow. It cannot field the lasers and railguns required for the 2040s. It has to be replaced. So, as the Navy prepares to retire the first Burkes in 2030, what is the plan to replace them? According to the news, the Navy is not building another destroyer. They has officially canceled DDG-X Next Generation Destroyer program. Instead, they are proposing an absolute monster. They are looking at resurrecting the battleship. Informally dubbed the Trump-class battleship, the latest intelligence confirms that the Navy wants this new behemoth to be nuclear-powered. Let's look at the terrifying paper specs. This ship is projected to displace over 30,000 tons. That is more than 3 times the size of a current Arleigh Burke. By utilizing a nuclear propulsion plant similar to an aircraft carrier, the battleship would possess unlimited range and, crucially, a bottomless reserve of electrical power. It is designed to be the ultimate arsenal ship. It will carry hundreds of vertical launch system cells, loaded with hypersonic missiles, high-energy laser interceptors, electromagnetic railguns, and potentially even sea-launched nuclear cruise missiles. It is not designed to escort an aircraft carrier. It is designed to operate independently as a flagship, projecting an impenetrable bubble of imperial firepower off the coast of any adversary on Earth. But then you look at the price tag. A single nuclear-powered Trump-class battleship could cost upwards of $17.5 billion. That makes it more expensive than the USS Gerald R. Ford aircraft carrier. It would be the most expensive single warship ever built in human history. But this is actually a brilliant investment. A $13 billion aircraft carrier requires a massive escort of billions of dollars worth of destroyers, cruisers, and supply ships just to survive. The Trump-class battleship, heavily armored and brimming with its own integrated air defense lasers and endless magazines, is an independent node. It does not need a babysitter. It projects an impenetrable bubble of imperial firepower off the coast of any adversary on Earth, all by itself. The US Navy plans to buy 15 of them, with the first one entering service around 2036. And this monumental program is doing something even more important than building a ship. It is saving the American defense industrial base. For years, peoples have warned that the American shipbuilding industry is in decline. It's true that currently, Newport News Shipbuilding in Virginia is the only facility certified to build nuclear-powered surface ships, and their docks are busy with submarines and aircraft carriers. But the Pentagon is playing multi-dimensional chess here. The Trump-class battleship program is not just a weapons procurement. It is a federally mandated shock to the system. It is a deliberate, calculated catalyst to reignite the arsenal of democracy. You don't rebuild a national industrial base by ordering small, cheap patrol boats. You rebuild it by setting an impossibly high bar that forces total industrial mobilization. By committing to a fleet of 30,000-ton nuclear battleships, the US government is signaling to the defense industry that the era of budget-cutting stagnation is over. This $17.5 billion price tag per ship is a direct injection of capital into the American heartland. This massive program provides the financial justification required for shipbuilders to construct brand new dry docks, modernize their heavy manufacturing equipment, and aggressively hire. It guarantees decades of high-paying, highly skilled jobs. It forces the expansion of the nuclear engineering workforce, pushing universities and trade schools to train the next generation of American shipbuilders. Just like the Reagan-era 600-ship Navy buildup of the 1980s, which revitalized the defense sector and outproduced the Soviet Union, the Trump-class battleship is the exact adrenaline shot the US supply chain needs. It proves that the United States is ready to out-innovate, outspend, and outbuild any peer competitor on the planet. To jump from an 8,000-ton conventionally powered destroyer directly to a 30,000-ton nuclear battleship is an incredibly aggressive, bold leap, and it is exactly the kind of visionary ambition that built the US Navy into the greatest maritime force in human history. As the clock ticks closer to 2030, the retirement of the early Arleigh Burke-class will undoubtedly mark the end of an era. This ship didn't just hold the line, it defined it. It survived budget cuts, enemy threats, and the failure of its own high-tech successors to remain the deadliest ship on the ocean for 40 years. But when the Burke begins to step back, the United States Navy will not be stepping backward with it. The torch is being passed. The proposed nuclear battleship proves that the Pentagon has completely shaken off the complacency of the last 2 decades. They are no longer playing it safe. They are thinking massive. They are designing for total dominance, and they are leveraging the full, terrifying financial and industrial weight of the United States to build a ship that will rule the 21st century. When that 30,000-ton Leviathan finally touches the water, it will perfectly replicate the oppressive, inescapable presence that the Arleigh Burke brought to the oceans 40 years ago. But I want to know what you guys think. Is the $17.5 billion nuclear battleship the ultimate visionary weapon to defeat anti-access area denial networks? And how excited are you to see the US shipbuilding industry get the massive federal funding it needs to expand and modernize? Drop your thoughts down in the comments section below.